Hello friends, myself Dattatrey Jadhav. I am from HM College Karad. Today we are going to discuss some special integral formulas in indefinite integration. There are 7 formulas for special integrals. These formulas are: first one is integral 1 upon x square plus a square dx. Second one is integral 1 upon x square minus a square dx. Third one is integral 1 upon a square minus x square dx. Fourth is integral 1 upon root of a square minus x square dx. Fifth one is integral 1 upon square root of x square minus a square dx. Sixth one integral 1 upon square root of x square plus a square dx. And seventh one is integral 1 upon x root of x square minus a square dx. Look at in these formulas of integration, numerator contains 1. Here numerator is 1, here is numerator 1, numerator is 1, numerator is 1. In all the formulas, numerator is 1 and denominator contains, here is a variable term. Denominator contains variable square, denominator contains variable square, variable square. Variable square, variable square, one term of variable square, and second is constant square. A is constant. In mathematics, first alphabets are used to denote variables, and first alphabets used to denote constants, and last alphabets x, y, z are used to denote variables. So denominator contains one variable square and one term of constant square. But the signs are different in each case. In these formulas, denominator is without square root, and in these formulas, denominator is with square root. Look at here. For denominator is without a square root, such a type of formulas are started with 1 upon a, 1 upon 2a. Now, look at here. Here a square minus x square is factorized by using a square minus b square, it's a minus b into a plus b. X square minus a square, which is also factorized as x minus a x plus a. But x square plus a square cannot be factorized here. Therefore, here is starting with 1 upon a. And here are two factors of x square minus a square, x minus a and x plus a. So starting with 1 upon 2, 2 is there. 2 into a, 1 upon 2 into a. Factors are a square minus x square, factors are a minus x, a plus x. So, first formula is for tan inverse x divided by a plus constant of integration c. Remember, first formula when 1 upon a is there, then it is of tan inverse x upon a, 1 upon a tan inverse of x upon a. But remaining two formulas where denominator is factorized, that formulas are started with log of mod. In numerator, here the factors are x minus a and x plus a. Write in numerator negative factor x minus a. In denominator positive factor x plus a plus c. When we write negative factor, if the first term is square of variable, and in this formula first term is started with a square, which is a square of constant, and constant may be positive. Remember as this, the factors of a square minus x square are a plus x, a minus x. Positive factor a plus x divided by a minus x plus constant of integration. If we write positive factor in numerator, then write negative factor in denominator. Why in 4th, 5th, 6th and 7th formula. In 4th, 5th and 6th formula, there is no term of 1 upon a, 1 upon 2 in such a, because there is a square root in denominator. First formula is clearly its sine inverse x divided by a plus constant of integration c. Remember, for integration of 1 upon square root of a square minus x square dx, it's clearly sine inverse x upon a. For these two formulas, they are started with log of mod, like this, log of mod. Not here factors are there. First term is x in both the formulas. First term is x plus what is the denominator? Right there, root of x square minus a square plus constant of integrations. Log of mod of x plus denominator. What is denominator? Root of x square plus a square plus constant of integrations. What is the formula for 7? Integration of 1 upon x root of x square minus a square. If I can take instead of a there is 1, then it looks like 1 upon x root of x square minus 1, and integration of such type of formulas are its sec inverse x. So that integration, since a is there, that started with 1 upon a into sec inverse of, here is the term x divided by a plus constant of integrations, and integration of 1 upon, consider a as 1, root of 1 minus x square dx is its sine inverse x, but because of a is there, its sine inverse x divided by a plus constant of integration c. Now we prove some special formulas. I am proving 3 to 4 formulas from these. First one is the third one, it's fourth one and fifth one in this lecture, and remaining are for homework. Clearly, starting with first formula, prove that integration of 1 upon x square plus a square dx is equal to, it's 1 upon a into tan inverse of x divided by a. So here is the question. The question is asked for 3 marks. Prove that integration of 1 upon x square plus a square dx is equal to 1 upon a tan inverse of x upon a. Remember here, for proving this result or for proving some special integrals, we remember about expression and substitutions. If expression contains a square minus x square, a square plus x square and x square minus a square, what are the substitutions? For a square minus x square, 1 minus something square, 1 minus sin square, so x is equal to a sin theta. A square plus x square, consider a as 1 plus something square, 1 plus tan square, so x is equal to a tan theta. X square minus a square, something square minus 1 plus tan square theta is equal to sec square theta. So sec square theta, tan square theta is equal to sec square theta minus 1. So x is equal to a sec theta. These are the substitutions for these expressions: a square minus x square, a square plus x square minus x square, or for square root of a square minus x square root of a square plus x square root of x square minus a square. Remember, these are substitutions for without square root, also with square root. Now, look at here. To prove, I can consider or let I is equal to integration of 1 upon x square plus a square dx. Look at here, a square plus x square dx, put x is equal to a tan theta. This formula can be proved using the substitution x is equal to a tan theta. So I can put here x is equal to a tan theta. When we substitute for a variable to new variable, we differentiate. So I can write here on differentiating. Derivative of x is 1. with respect to x. So multiply dy dx, 1 into dx dx is equal to a constant as it is, derivative of tan theta is sec square theta. Since RHS is in theta, so multiplied by d theta. So dx is nothing but a sec square theta d theta. So integration becomes I is equal to integration of 1 upon x square. X square is nothing but a tan theta bracket square plus a square into, instead of dx I can write here a sec square theta d theta, which is equal to integration of 1 upon, look at here, a tan theta bracket square, a into b bracket square, a square into b square. So a square into tan square theta plus a square into a sec square theta d theta. Integration becomes I is equal to, now in these two terms a square is common, so I can write I is equal to integration of, taking a square common from denominator, a square into bracket, what's remaining here, tan square theta plus 1 into a sec square theta d theta. 1 a get cancelled, 1 a is remaining in denominator, taking that constant outside the integration, 1 upon a into integration. 1 upon 1 plus tan square theta is nothing but a sec square theta into a get cancelled, what's remaining here, sec square theta d theta. These terms are cancelled. Sec square theta divided by sec square theta is what, 1 upon a into integration of 1 with respect to theta. Integration of 1 is x with respect to x, and integration of 1 with respect to theta is theta plus constant of integration c. Here we evaluate that integration, but answer is in variable theta, so resubstitute for theta. From this substitution we find the value of theta. Yes, x is equal to a tan theta, therefore tan theta is equal to what, x divided by a, therefore theta can be written as tan inverse x divided by a. So I is equal to 1 upon a as it is into value of theta is tan inverse x divided by a plus constant of integration c, and it is to prove integration of 1 upon x square plus a square dx is equal to 1 upon a into tan inverse of x upon a plus constant of integration c. For example, integration of 1 upon x square plus 4 dx is equal to, I can write this as integration of 1 upon x square plus 2 square dx. It looks like 1 upon x square plus a square dx. So formula is 1 upon a, but a is what, 2? 1 upon 2 into tan inverse of x divided by 2 plus constant of integration c. So next formula is to prove, you have to prove integration of 1 upon, I can take here next formula, second formula, integration of 1 upon x square minus a square dx. Integration of 1 upon x square minus a square dx is equal to, since there are two factors, formula is started with 1 upon 2a into log of mod of, yes, factors are x minus a and x plus a. Take negative factor, since we started with variable x minus a divided by x plus a plus constant of integration c. To prove this formula, look at here, first in solution we write let I is equal to, consider the integration by I, so let I is equal to 1 upon x square minus a square dx, integration of 1 upon x square minus a square dx. For this formula substitution is different. For this formula proving expression is x square minus a square, so substitution is different. But for second and third result we are it is more convenient to use partial fraction without proving substitution. So I can solve this corollary, or I can prove this formula by partial fraction. Look at here, I can be written as 1 upon, I can be written as integration of 1 upon, its factors are x minus a into x plus a dx. Now look at here, carefully, 1 upon x minus a into x plus a. Here are two factors. I want to write these two factors as 1 upon x minus a plus or minus, something is there, I don't know where it is plus and minus, but plus minus 1 upon x plus a, like this. But what if we write add or subtract, plus or minus, the variable x is eliminated. If we write here plus, then x is not eliminated. Why? Because when maintaining or taking LCM on both the sides, it's x plus a into x minus a. So what happened here? Here is x plus a plus x minus a. Means which term is not omitted here? Variable term is not omitted here. To eliminate variable term, I can take here write as 1 upon x minus a minus 1 upon x plus a. So what happened here? X plus a minus x minus a, this term becomes, which is equal to plus x minus x get cancelled, plus a minus minus plus a. It's nothing but 2a divided by x plus a into x minus a. But I want to write this term as in the form of this. Look at here, 2a is here extra for this. So I can adjust here 1 upon 2a. It's expression of the above terms. It is the expression of the above terms. So I can write 1 upon 2a into above terms means what? 1 upon x minus a minus 1 upon x plus a. Look at here, denominator is what? X minus a into x plus a. If we multiply 1 by x plus a minus x minus minus plus a, plus 2a, 2a, 2a get cancelled. Means we write 1 upon x minus a into x plus a as 1 upon 2a into 1 upon x minus a minus 1 upon x plus a. For proving third result, use plus sign is there in between two. So integration becomes, yes, 1 upon, instead of that term I can write this 1 upon 2a into x minus a into, sorry, it's 1 upon 2a into 1 upon x minus a minus 1 upon x plus a. If we simplified this, then we get that term. Here 1 upon 2a is constant, so take outside the integration. Integration of its 1 upon x minus a minus 1 upon x plus a dx. Inside the integration there is addition. Inside the integration there is addition. So we separate integration sign. So integration becomes I is equal to 1 upon 2a as it is into integration of first term, that is 1 upon x minus a minus integration of second term, that is 1 upon x plus a, and this is the bracket since 1 upon 2a is into for both the terms. Consider that x minus a as x and x plus a as x. Integration of 1 upon x is, integration of 1 upon x is log of mod x. Integration of 1 upon x minus a is log of x mod of x minus a divided by coefficient of x, that is 1, minus integration of 1 upon x plus a is log of mod of x plus a divided by coefficient of x, that is 1, plus constant of integration c, which is equal to 1 upon 2a. If we don't write 1 there, it is also okay. Log m minus log n, it's log of m upon n, so log of mod of m is what? X minus a divided by n is what? X plus a plus constant of integration c. Hence the proved. Here is the reason for that stage is log m minus log m is nothing but log of m divided by n. Similarly, you can prove third result. Now, for example is here, evaluate integration of 1 upon x square minus 4 dx. Here is square of variable, so I can write integration of 1 upon x square minus this as 2 square dx is equal to, starting with 1 upon 2a. What is a? 2. 1 upon 2 into 2 into log of mod of. The factors of x square minus 2 square is x minus 2x plus 2. Since started with variable, which factor is in numerator? Minus x minus 2 divided by x plus 2 plus constant of integration c. 1 upon 2 into 2 is what? 1 upon 4, like that. Now, here we prove another result. Prove that integration of 1 upon square root of a square minus x square dx is equal to, it's nothing but what? Remember, when there is a square, consider in square root, consider it's 1. A is 1, 1 square is 1, 1 upon root of 1 minus x square dx. Integration of 1 upon root of 1 minus x square dx. It's sine inverse, so it's for sine inverse, but here is x upon a plus constant of integration c. So, to prove integration of 1 upon root of x square minus x square dx is equal to sine inverse x upon a plus c, consider or let I is equal to, in solution I can write I is equal to integration of 1 upon root of a square minus x square dx. A square minus x square dx. Now, moving to expression and substitutions. What is the substitution? Yes, put x is equal to a sin theta. Since for root of a square minus x square, substitution is a sin theta. On differentiating, derivative of x is 1. Since it is differentiated with respect to x, multiply it by dx is equal to a constant, as it is derivative of sin theta is cos theta. Since it is differentiated with respect to theta, so multiply it by d theta. So integration becomes I is equal to, what happened with our integration? 1 upon square root of a square minus, what is x? It's a sin theta, bracket square, into, instead of dx I can write a cos theta d theta, which is equal to integration of 1 upon square root of a square as it is minus, using which formula? A into b bracket square, a square into b square. So it's nothing but a square into sin square theta into a cos theta d theta. Taking what common? A square. So integration becomes I is equal to integration 1 upon, taking a square common in square root, a square into 1 minus sin square theta into a cos theta d theta, which is equal to integration 1 upon square root of a square, or writing a square as it is. 1 minus sin square is what? Cos square. So 1 minus sin square theta is cos square theta into a cos theta d theta, which is equal to 1 upon square root of a square. Square root get cancelled. It's a square root of cos square. Square root get cancelled. It's cos theta into a cos theta d theta. What happened? A get cancelled, cos theta get cancelled. Its integration of clearly 1 with respect to theta. Integration of 1 is theta plus constant of integration c. But what is theta? Because of our substitution, answer comes in theta. So I find your value of theta. From x is equal to a sin theta, we write sin theta is equal to x divided by a. Therefore what? Theta is equal to, take sign on RHS. Trigonometric functions becomes inverse trigonometric functions. Sin inverse x divided by a. So I is equal to theta is what? Sin inverse x divided by a plus constant of integration c. Hence the proof. Hence the proof. Here is, for example, if integration is of 1 upon x square minus 4 minus x square in square root, then I can write this as integration of 1 upon square root of 2 square minus x square dx. Since one term is of variable square, I can write 4 as a constant square. And using this formula, integration of 1 upon square root of x square minus x square dx is equal to sin inverse of x upon a. So I can answer of this question is sin inverse x divided by 2 plus constant of integration c. Now proving last result in today's video. Prove that integration of 1 upon square root of x square plus a square dx is equal to log of mod of x plus square root of x square plus a square plus constant of integration c. That is log of mod of x plus, what is this? It's a denominator. Log of mod of x plus denominator plus constant of integration c. Look at here. Remember, all these 7 formulas are proved by substitution. Remember, about second and third we use partial fraction. It is easy, too easy calculate these formulas. Now first I denote this integration by I, let I is equal to integration of 1 upon square root of x square plus a square dx. Look at here, square root of x square plus a square is there. So what is the substitution? Put x is equal to a tan theta. Substitution is what? X is equal to a tan theta. Therefore, on differentiating, dx is what? A as it is, derivative of tan theta is sec square theta d theta. Therefore, I can be written as I is equal to integration 1 upon root of x square. What is x? A tan theta. A tan theta bracket square plus a square as it is into dx is what? A sec square theta d theta, which is equal to integration 1 upon square root of, on simplifying, a tan theta bracket square is nothing but a square tan square theta. So I can write integration 1 upon square root of a square tan square theta plus a square into a sec square theta d theta. Taking a square common inside the square root sign, so integration becomes I is equal to integration 1 upon square root of a square into bracket tan square theta plus 1 into a sec square theta d theta, which is equal to integration 1 upon square root of a square as it is 1 plus tan square x is sec square x, so 1 plus tan square theta is sec square theta. Integration of 1 upon square root of a square sec square theta into a sec square theta d theta. What happened here? Square root of a square is a and square root of sec square theta is sec theta into a sec square theta d theta. A get cancelled and 1 sec theta get cancelled. What's happening here? Sec theta with respect to theta. Integration of sec theta with respect to theta is log of mod of sec theta plus tan theta. Log of mod of sec theta plus tan theta plus constant of integration c. Here is the solution of the integration, but answer comes in which variable? Theta. Now when we are converting theta in terms of x because of our substitution. Substitution is x is equal to a tan theta. here is equation number first. X is equal to a tan theta. This is equation. Suppose that equation is number star. From star, tan theta can be written as tan theta is equal to x divided by a. Take a on LHS, tan theta is x upon a. Means we get the value of tan theta. Now what is remaining? Sec theta. And we have what we have? Sec in terms of tan. Sec square theta is nothing but 1 plus tan square theta. Sec theta is what? Square root of 1 plus tan square theta, which is equal to, now tan theta is x upon a. Sec theta is what? 1 plus x divided by a bracket square, which is equal to 1 plus separating square x square divided by a square, making denominator same in square root. Therefore sec theta is equal to, sec theta can be written as root of a square plus x square divided by a square, which is equal to, yes, separating root to denominator and numerator, it's root of x square plus a square, and square root of a square is a, its value of sec theta. Put value of sec theta and tan theta in equation number first. I can write here. Put the values of sec theta and tan theta in equation number 1. Therefore equation first becomes, what happened with equation number first? Look at here. In equation first is I is equal to log of mod of sec theta is what? Root of x square plus a square. Root of x square plus a square divided by a, plus tan theta is what? Tan theta is x divided by a plus constant of integration c, which is equal to log of mod of. Here denominator is same, addition of numerator x plus square root of x square plus a square. I can write log of mod of x plus square root of x square plus a square divided by a plus constant of integration c. But in RHS or prove that there is no term in denominator, so I can write this as log of mod of x plus square root of x square plus a square minus log of a plus constant of integration c. Why? Because log m upon n is nothing but log m minus log n. So using that formula. But in RHS the term is as log of mod of x plus square root of x square plus a square plus constant of integration c. But here are the terms minus log a plus c. For here is c, I can consider the above constants in the integration as c1. And look at here, c1 is a constant, a is a constant, log of a is a constant, c1 minus log a, which is again a constant. Since I introduce here c, where c is equal to c1 minus log a, which is to prove I is equal to log of mod of x plus square root of x square plus a square plus constant of integration c. Hence the result. Students, you must remember these formulas, because in next 5 to 6 types of integration, indefinite integrations, the formulas are used. Special integral formulas are used. I hope you understand today's formulas on special integrals. Solve the remaining formulas for homework. Thank you for watching the video.